$100 to a local food establishment. We'll announce those the following morning. So today's game, movie characters, announce one number of you stopped in. We'll announce the winner tomorrow morning. We sign up once. Tuesday's theme is nerds versus jocks. Information on the Young Light All-Nighter. Trip to the Mall of American Valley Fair. Stopping you off to pick up the flyer. If you've not done so, contact Mike if you have any questions on that outing. Make sure if you're planning on bringing an out-of-school guest to the dance on Friday evening that you turn in the form Thursday morning. You will not be allowed into the dance without that form and a picture ID. For you, that's your school ID. So please stand for the pledge. Pledge allegiance to the flag
of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay.
Anyone? Almost? Okay. Now, let me see if I can't type with Frank here. Is negative x to the fifth. Three x third squared plus 3x. You actually gonna work this time? Maybe. Could be. Chance of. Okay. Skadoosh. Find and label all the extrema of the function. What is extrema? Okay, those are types of them, relative or absolute, maximum or minimum. Its definition is that it's where it changes from increase to decrease or decrease to increase. So I plug all the stuff in the calculatron, I go to my graph, we say, come on, Frank. Oh, random tidbit in trivia, you'll hear LeVar Burton shot down Jeopardy. There's a big campaign to make him the new Jeopardy host. The producer chose himself instead after this big whole spiel, and then it turns out he's a racist sack of crap. So now he's fired before he even started. Yeah. Sorry, Jeopardy theme. Bouncing ball. There it is. We have calculate. I see two extrema on here. I see one that appears to be between -2 and 0. So we're going to say, is that a... Come on, Frank. Thank you. What is it, though? Relative minimum. So we should have a relative minimum approximately -1.233, -7.931. Do it again. Calculate. Maximum. Somewhere between 0 and 8. Right? Doesn't matter where I put them as long as they're in that area. Wow. Oh. Another relative. This time maximum. This one's at 2.151, 1457. What about that? What is it? Not intersection. Inflection, okay? It is a point of inflection. You did not have to state it because a point of inflection is not extrema. The rate of increase changed. It was still increasing, okay? So we don't say that one. And then what is the average rate of change on the interval from, was it -1 to 3? -1 to 3. Honestly, to find that, I would just trace this while I'm here and say at -1, what do we got? So the rate of change is x2 minus x1, y2 minus y1. So here it's at -7. And also to what, 3? Negative 27. Holy smokes. So you'd think from here to, man, if I had said 2, that would be a whole different ballgame, right? But we said from negative 1 to 3. Well, that's like way down here. I didn't even hit the point. Wow. I didn't even look at the point. So average rate of change, right? There's this whole spike here, but if I try to combine everything together, we've got negative 20 over 4, negative 5. That's it. Did you correct point, correct name, correct rate of change? Name, point, rate of change. Yes, sir. Ruh-roh. Whole bunch of different numbers. Go back to your original. Look at the equation itself. Most common error is going to be right here, accidentally using a negative button instead of minus button. No? Okay. You had your 2 extrema. You called them the correct thing, whatever they are. You found them. You did your rate of change. You did all the things, just with not that. 4 out of 5. Okay. Homework. 'Tis been about 70 hours, and I don't know that I heard a single question. Talk to me, Goose. Anything? Maybe, could be, chance of. All right, cool. Moving on. Transformations. I beat this to death last week with Algebra 2 because they first started talking about transformation form function families. What is this? Oh, okay. Before we can talk about transforming functions, quick trip down memory lane, the types of functions that you have encountered thus far. You have constant function, y equals 5. There's no variables in it, so we call it a constant function. Doesn't matter what x is, y is always this. Okay, that's pretty basic. How many of you knew that linear functions were called identity functions? Okay. Do you see why it's called the identity? The input is the output. For example, Aubrey, what's your name?
Aubrey.
Input was output, right? It's almost like that's her identity. So, all I got to do is move that line around, all that kind of stuff. Okay. Square root, y'all remember it has an origination point. You deal with the principal root of it. So I don't have plus or minus, because if I had plus or minus, this would not be a function. It wouldn't pass a vertical line test. So we always restrict the range and say it's only the principal root. Y'all remember graphing them, perfect square steps, right? It's still the same parabola square steps, 1, 1, 2, 4. 3, 9. It's just on the side. Okay, and then we transform it, move it around, do the thing to it. Quadratics, we reviewed that. Okay, cubics. You remember that cubics can use cube steps the same way that quadratics use perfect squares. To graph these, you will have a, if it's in transformation form. Like as soon as the cubic starts getting weird, okay, that's not going to have an inflection point in the middle that you move around. It's just going to be this goofiness, okay? So if it's in transformation form, they're always going to have this inflection point in the middle, and from there, 1 cubed is 1. 2 cubed is 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8, and so on and so on. So we introduce those as functions and graphs in Algebra 2. Reciprocal function we haven't seen since Algebra 1. We are remedying that. Mr. Spear and I have been talking for a couple years about needing to move rational functions in Algebra 2 instead. So we're starting that this year. The idea behind them is you get this crosshairs of vertical and horizontal asymptotes. We saw them intermittently over the last few lessons. But when I transform this thing and I move it up, down, left, right, I'm basically taking that crosshairs and I'm adjusting it. And then you move based on wherever the crosshairs are. All right. Okay, absolute value. Just did that with Algebra 2 last week. Absolute value is not a quadratic. I don't know why, but for some reason, if I ask for this, translated 5 units this way, 4 units, whatever, a whole bunch of transformations, I'll have kids decide to write this. They'll just turn it into a quadratic. Don't do that. Okay. 2 different graphs. One's a V, one's a U. Okay. It's got curves. It actually eats things. It's afraid of M&Ms. All right. One that you probably haven't seen since all the way back in Algebra 1, if that. Greatest integer or step functions. Look familiar? Okay. A greatest integer, or they call them step functions too, just like a identity function is called a line linear function. You see why it's called steps, right? Step functions. Looks like steps. The idea behind these is when you're not allowed to have a non-integer answer. Case in point. Andrew is going to go buy a whole bunch of little mini boxes of cereal. Okay? Like those ones that you take camping or whatever, right? Or now they come in the pouches, okay? And can Andrew take one of those? One of those usually like $2 pop, maybe?
I don't know, my mom buys them.
Yeah. We'll say they're 2, okay? You take one, throw it in the cart, $2. Take one, throw it in the cart, $4. Take one, throw it in the cart, $6. Can you say, I have $7.50 in my pocket, so I can buy 1, 2, 3, and 3/4? Right? You can't do that. So you need to have integer values only. That's what a step function is. I can only buy 1 chair. I can't buy part of a friggin' chair. But then I can buy 2 chairs. Then I can buy 3. And so on. So the way the graph works is when I'm at 0, what is the biggest integer I've ever seen? Number line, 0, right? 0 is the biggest number I have ever encountered. When I'm at a half, what's the biggest integer I've ever encountered? Still 0. When I'm at 0.9999999, what's the biggest integer I've ever encountered? All the way up until, this is why it's open circle, as soon as I hit 1, what's the biggest integer I've encountered? Okay. The biggest I've seen is 1111111. At 1.999999999, it's still 1, and then at 2. Now the biggest integer I've encountered is 2. Okay? So that's what a step function looks like. Honestly, they're not difficult at all. They're annoying because they take longer to graph. Because it's dot, dot, dot. It's annoying to graph, but they're easy to understand. Think of it as it's just double brackets. Okay? That's greatest integer. So it was probably shown to you once, like in an extension or something back in Algebra 1, but that's it. All right. First, now that we've done all of the analysis stuff, the first half of Chapter 1 is, can you analyze a function? Start to finish, tell me all the things about it. Here's how you do a symmetry test. Here's how you do a continuity test. Here's how you determine domain and range. Here's how you do all the things and prove them. Well, now I can just say them. Just like in geometry, after you proved theorems, you didn't have to reinvent the wheel. You just said angle side angle congruence theorem. Okay? So use the characteristics of the graph to tell me all the things. You're going to tell me domain, range, x-intercept, y-intercept, symmetry, continuity, end behavior, which we will write as limits. Limit of my function as x approaches. Limit of my function as x approaches. Increase, decrease. I'm gonna zoom in, just chill, okay. Of f of x is the square root of x. Okay? You got to tell me all this stuff about this graph. So you have to know what the parent graph, square root of x, looks like. Well, parent graph has an origination point at 0, 0, and then moves by square root. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And it heads off into the wild blue yonder, like so. So then you got to tell me all the stuff about it. What's the domain of this function? Interval notation, please. What x's are allowed to the party? Okay, not everything. From 0 to infinity, right? That's our second commandment of domain. Thou shalt not take even root of negatives. So from 0 to infinity. When I plug in 0 through infinity for x, what comes out of that as y's? What's the lowest that the y's ever go? Also 0. What's the highest they ever go? Also to infinity. It just takes longer to get there. X-intercept. Well, looks to me like it hits the x-axis at 0. Same for y. See, I don't have to go proving it. The reason we did all the analysis is so if you think it's this but you're not sure, now you know how to be sure. Symmetry. Nothing. It's not symmetric to anything. Continuity. Are there any gaps in it? Is there any vertical asymptotes? Are there any holes? Or is there any jump discontinuity? No. So it is continuous, but you have to say continuous where? Because if I just say continuous, I'm assuming all real numbers. But is it continuous back here at -6? So I have to say continuous at 0 to infinity. Continuous along its domain. End behavior. Well, as I go out to infinity, I know that my y's also go to infinity. Do you remember how we said the left end behavior of something that does not exist past a certain point? Okay, as I approach 0 from the right, from the positive side, it approaches 0. Again, if I remember right, the book and the solutions will say as it approaches negative infinity, it doesn't exist. Just know that those are two different schools of thought. One says end behavior is always negative to positive infinity. The other is from left to right ends of its domain. Intervals increase and decrease. Well, from 0 to infinity, that thing's always headed up, never headed down. Okay. Now, the reason that I wrote it all in a big column like this, homework hack. What happens when this is number 1, but then you have to do it again 3 more times? What I would do is just like this and write all this stuff off to the side. Treat it like a table. That way you don't have to write it as many times. Okay? So, we're going to do the same thing, but you go away, you go away, you go away, you go away. And you go away. We're going to do the same thing, except got it 1 is absolute value of x. You got to know what that looks like. Go! Cat timber?
Ferrets.
Oh. Ferrets have a distinct smell. Like, I don't know if anyone's ever had a ferret as a pet. Like, they have a very distinct smell. Yes.
So on the one above, why did you add the increase with parentheses? Because wouldn't 0 be included as an increasing point?
If you're at a stop sign, are you speeding up or slowing down?
Or not?
Neither.
Okay, so that's why.
You always use parentheses for intervals of increase and decrease. Okay, first you got to know what the graph looks like. Then you got to tell me all the stuff about it. Remember, talk to your neighbors, argue, discuss it. If it's dead quiet while we're doing thing, if it's not a daily quiz or a test, I get concerned. Okay, chat it up. Either in the math menu or if you're on 84, alpha window will bring up something called abs. Give your function abs.
Oh, gotcha. It's his job.
Yeah.
It's all real numbers, correct?
What's up?
Symmetry, we're just asking for axis of symmetry?
X, Y, origin, or nothing.
But you don't have to do a symmetry test, so you just have to
Yeah, you just say it.
say it.
Just say it.
Over the y-axis.
Well, if you were to actually test it, what is symmetric to the y-axis as a test? I negate x. Well, that just ends up the same,
Oh, yeah.
right? So that's it. That's your test. Seriously, did you make it, or was? Well done.
When my brother got his yeah.
Zero.
Okay, I got to do conversational tangent. If y'all are liking the whole like dress up for homecoming thing, and when someone just nails it, just search social media wherever Gen Con cosplay. Okay, because Gen Con was I think this past weekend, and the cosplay artists that go through there, the costumes that they make are just insane. Really good. Like I saw a full articulated General Grievous. Like, yeah, good stuff. If you don't know who General Grievous is, your childhood was deprived. Okay, it looky like this. It's got a vertex at 0, 0. You're talking about the distance from 0. If I go 3 to the right, the distance from 0 is 3. If I go 3 to the left, the distance is still 3. That's why it makes a V. That's why it's symmetric and it has an axis symmetry. Domain. Everybody allowed to that party. I can put whatever I want in absolute value. However, the range says that it's always going to come out as a positive number, or 0 when it's at the vertex. Okay? X and Y intercepts, you can cheat and just do both at the same time. 0, 0. My symmetry, symmetric to the y-axis, because if I were to negate x, well, absolute value of whatever, it's still positive. So your test is pretty simple for it. Continuity, it is, again, continuous for all real numbers. I never got to pick my pencil up making an absolute value graph. End behavior, as I approach both negative and positive infinity, it heads up to positive infinity. Increase from 0 to infinity, my pencil goes up. From negative infinity to 0, my pencil goes down. Okay? Left to right, across the number line, is your pencil going up or down. That's your increase and decrease. So, this idea of can you tell me all the stuff about a function is going to come up a lot in the next few weeks, where every time we review a type of function, this is how we start. In fact, the rest of this class, anytime we talk about a new function, okay, cool, analyze it. Tell me all the stuff about it. If I give you any function, you should now be able to tell me this stuff. We went through all the tests. We went through how do I find the x-intercept of random pile of gibberish? Well, how do I find the x-intercept of random pile of gibberish? Not x is 0. Set the y equal to 0 and then solve. Okay? Whew! Y'all remember this stuff? Translate up, down, left, right, vertical stretch, vertical compression, vertical reflection, horizontal stretch or compression or reflection. And additionally, we're also going to have absolute value stuff. I got this spot up here blank for a reason. This is where we're going to put the Holy Grail. Y is f of and you're like, oh, well, there's all these spaces. A, B, H, and K. Regardless what the parent function is, you have a grouping in with X. So, example, I could write Y is a square root of bx minus h plus k. I could write y is a over bx minus h plus k. I could write y is a bx minus h to the nth power plus k. Whatever the grouping is of x. Doesn't matter what type of function it is. A is the crap out front. K is the crap at the end. B and H are the stuff that are grouped in with it. There needs to be parentheses or a radical or absolute value brackets. There has to be something putting them together. And they all do a very specific thing. A does three things. If A is negative, it's called a vertical reflection or reflect in the x-axis. The reason that it can be called both is if you reflect in the x-axis, the order that I perform my transformations in matters. But if I say vertical reflection, I can reflect about a vertex or a point of inflection any time in the transformation process. Okay? So, depends on order that you say it in. If the absolute value of A is less than 1, think about this in terms of your paycheck. Okay, good chunk of you either working now or you have worked in the past. What happens when your parents set this criteria that says half of your paycheck has to go into savings? Okay, half of I do all the work, whatever happens, happens, and then I multiply it by a half. You take your earnings and cut them in half. That is a vertical compression. It compresses the graph. It cuts your output in half. But what happens if maybe you're working towards a car? Okay, I'm going to make this much money, and your parents say, cool, whatever it is, we'll match it. You decide how much you want to spend on a car, we'll match. A, privilege much. B, that's a stretch, a vertical stretch. Because whatever you had for your income, maybe it was doubled. Okay? I know a lot of families will do something like that. We'll match up to a certain point. Like we'll put in up to $2,000. Okay, we'll match it up to that. 4,000 for a high school car is pretty good. Like that's a good vehicle. I personally believe that you should all have a giant piece of crap for your first car because you didn't buy it yourself. You don't respect it until you put your own resources towards it. Who? Okay, let's throw some shade. Who in here's got the mommy daddy car? No shame. Me. Like they bought you that car that is easily easier. It's better than half the teachers. Okay.
My car's not better than them, but they bought me my car.
Have you seen what Banton's rolling around in? He's got this like beat up old Toyota Corolla. It's gorgeous. We both come from Bell every day, so we're usually like passing each other playing bumper cars, right? Right now, I got the first new vehicle I've ever owned in my life, and my wife made me get it because we were having kids, and she didn't want a kid in my piece of crap truck that I had before. So it's a 2016 Silverado. But I bought the demo model, so it was only 28,000 instead of the like 50, 60 that most trucks are. Yeah, bare bones. And I'm still paying on it because I'm a teacher and I'm broke. Oh no. Okay. Anyway, moving on. B. Okay. B is going to do all the exact same stuff in bass-ackwards land. In bass-ackwards land. It's ironical because I'm saying ass backwards. So it's bass-ackwards land. Okay? Here's how it works. If B is negative, now it's not vertical stuff. Now it's horizontal. It's a horizontal reflection. Horizontal reflection or reflect in the y-axis. Okay?
Are those little circles just points?
Yeah.
Okay.
Like bullet points. Sorry. Here.
Yeah. I was like, what is this little circle? Oh.
Better?
Yeah.
Okay. If the absolute value of B is less than 1. Okay, I said this is bass-ackwards land. So if A was less than 1, it was a vertical compression. If B is less than 1, it's a horizontal stretch. And so think about it this way, B is less than 1. It's a horizontal stretch. If I have a graph that is like this is time and this is money and I'm trying to save up for my car, well, what happens when I take my function like this? You cut your input in half. What happens when your hours get cut in half? It it makes me very mad. Doesn't it take you longer to get to your goal? Your input was cut in half. So if before it was like this, well now, whatever you were making here, it's actually going to happen here. It cuts it in half. Your input is cut in half. So it has a reverse effect. It's going to take this graph and stretch it out like this. Right? Cut your input in half. It takes longer to get where you're going. So opposite effect. Well, that also means what happens when absolute value of B is greater than 1. Okay. Now it's a horizontal compression. But with both of these, this is the part that most kids miss, by the reciprocal. By the reciprocal. So if I put a half in here, if I cut my input in half, doesn't it stretch the graph out and take twice as long to get where I'm going? What happens if instead you double your hours? Doesn't it now take you half as long to save that money? Okay, so it always has the opposite effect when you mess directly with the input. That's why we call it bass-ackwards land. That is just fun to say. Okay, H. H is, put this next to it. It's just easier to remember it this way. This is a horizontal translation. So again, let's say we're saving up for that car. X is your input. This is the time I'm putting in. This is the money that I'm making. You drop your phone and crack the screen and you got to buy a new one. $200. I don't know what it costs. I got a new phone in the last like 10 years. So doesn't that mean if your graph is moving along like this is where I'm going to get my car, but you had to pay $200 for that phone? Doesn't that mean it now takes you longer to get to your goal because you had to pay money out? So that's why if I say minus 200, it's actually going to move the graph to the right because it now takes 200 longer to get where I'm going. Versus you had a birthday and a rich grandma. She gave you $200. Doesn't it now get $200 closer to your goal? You get there sooner. So now it's going to move the graph 200 that way. Okay, bass-ackwards land. It has the opposite effect on the graph when you mess directly with the input. And then finally, K is my vertical translation. It is outside the grouping of X. So it just does what it says. Whatever you have, I'm going to add to it. Okay? Now it's, you're going to do all your stuff, and then along comes, I don't know, some really drunk rich rancher who decides to tip you $300 because they're a misogynistic pig and they're going to say, cute girl. Okay? Okay, $300. Whoop! My income just went up. That's all it is. Okay? This is the Holy Grail. Like, does this look familiar? You should have beat the living snot out of this throughout Algebra 2. Like, bored. The first couple of times you do it in Algebra 2, a couple of kids get a little cross-eyed and they're a little confused. By the time you're not even halfway through the semester, you hit the end of the chapter and like, guess what? Now that we learned stuff, we're going to transform them. And everyone goes, ugh. And it's the easiest lesson of the chapter. Okay? I hope this is familiar. Because I am going to blast through the rest of this stuff. Use the parent graph to do the transformations. If I see the this, where's the 2? A, B, H, or K? H. Grouped in with X. Bass-ackwards land. What type of transformation is it? But we want to use big kid words and say it is a horizontal translation 2 to the right. Okay, use those big kid words. If I see a -1 out here, A, B, H, or K, in the K spot, big kid words, vertical translation, 1 unit down. Now, I can abbreviate those. If it asked me for the transformations, I would say horizontal translation, right 2. Vertical translation, down 1. Yeah, that's fine. But I at least want to see those words, horizontal or vertical translation. Horizontal or vertical reflection. Is it a horizontal or vertical compression or stretch? I want to see those words. Because what happens when you get a multiple choice test and like option C says a vertical translation two units up versus that. Let's be honest, multiple choice tests are just about a guessing game and whittling down the choices, right? How many of you would just see that, circle in, and just keep going because you're trying to beat the clock? But horizontal does not go up or down. Okay? That's why I want to use the big kid words to reinforce that, make it a little more automatic for us. If I'm going to graph that, it just means I'm going to take my vertex that was here, and then I move it 2 to the right, 1 down, and then make my graph. Y'all remember that for these, my vertex is always HK. My slope on the right side is always A times B. The combination of your vertical and horizontal dilations. So since there's a 1 here and a 1 here, it's just a slope of 1. There's a graph. So like, if this same thing had a 4 right there, every one of my outputs is multiplied by 4. That means I would still move right 2 down 1, but now I go up 1, 2, 3, 4 times as tall. 1, 2, 3, 4 times as tall. Okay? And notice that the slope on the right side is 4 over 1. A times B, 4 times 1. So, yeah, we can do that. 2C. Tell me what the transformations are. Graph the transformed function. Stop it. Womp womp.
Horizontal translation.
If you want us right now, can we just grab it?
I would like you to write the transformations as well, just to get a little bit of side practice in. Right? H and K spots. I know the difference between H and K because one is in the grouping, one is outside the grouping. A cubic typically has a point of inflection in the middle at 0, 0. So I take that point and I will move it 2 to the left, 4 up. I will say it's a horizontal translation, 2 to the left. It's a vertical translation, 4 up. I move my point of inflection, and from there I will now use my cubes to make the rest of the graph. Over 1, up 1. Over 2, up 8. So a little bit off-road. Left 1, down 1. Left 2, down 8. Left 3, down 27. So still off-road. Like so. They don't have to be perfect, but I want to see the points on there showing that I at least know where this goes. Okay? Cool with that so far? Cross those other 4 out so that I know that we just didn't do them. When I see a lot of blank spaces in notes, it really makes me sit up and take attention. But if I see that everyone is crossing it out, then I know what's up. Okay? Write the equations from the transformations. So first, you got to know what the parent graph even is. You got to know what the parent function is. If I see this, what is that? It's parabola. Parabolas are the graphs of quadratics. So I know that's the parent graph. I know that g of x is going to be, I'll leave a spot for a, b, h, and k. In Algebra 2, we did not see b very often because there was always a way to factor out the b value and turn it into an a. Case in point, we were just doing absolute value graphs with my Algebra 2 the other day. Like this. If they ask what this transformation is and how to graph it. First of all, what's A? 1. What's B? -3. What's H? No. No. -2/3. Ah, yeah, that's what we didn't see very often in Algebra 2. I have to turn that into B separated from X minus H, which means I have to divide it by a -3 to factor it out. Well, the reason that we didn't see B very often is because I can still separate that. I can call that absolute value of 3 times absolute value of X minus 2/3. Like this. But what is the absolute value of -3? This is this. This is how I determine my transformations. It had a horizontal reflection, or reflection in the x-axis. What happens when I take an absolute value and reflect it over the y-axis? It's still the same thing, right? Still the same thing. Notice that over here, when I can take the b and turn it into an a, it is now positive. Okay, because it doesn't actually affect the graph. It is still a transformation that I would have to write down, but the graph is not going to reflect that. If you laugh at that, you're sad. Don't give me pity laughs. That was terrible. So I'm still going to leave room for A, B, H, and K, even if most of the time we're not going to have B. Okay? Well, here's a vertex. I can take care of H and K pretty easy. Did it move left or right? It moved the right how far? 2.5. I'll call it 5 halves. Positive or negative? If I went to the right. Negative. Bass-ackwards land. Did it go up or down? No. Now here's the thing. Reflecting horizontally isn't going to do anything. So I'm just going to say that this is a 1. And I'm going to put all my eggs in one basket. I'm going to say that my reflection and my stretch are all part of my A, because I'm making the equation. Now, we know it reflected vertically, reflected across the x-axis, so there's got to be a negative there. How do I determine what A is? Think about the parent graph and what the parent graph is supposed to do. How does the parent graph move away from its vertex? Over 1, up 1. Over 2, up 4. You get this ratio of what did it do over what it should have done. It did this instead of that. It went over 1 and down 2. So if it went over 1 and instead of up 1, it went down 2, it did a -2 when it should have done a 1. A ratio of what it did over what it should have done. That's a -2 out front because it was stretched twice as far as it should have been. And then clean it up. G of x is -2, x minus 5 halves. Don't forget, someone could have called me on it, you're squared. Don't forget you're squared. It really sucks when you do everything right and then you get 4 out of 5 on that particular problem because you missed the exponent. Okay. Same thing for contestant number 2 here. I'll say g of x is, and I'll just leave some spaces like this. It did not move left or right. It did go up 2, vertical translation by 2. It did vertically reflect, and it went from the vertex over 1, down 1, over 2, down 4. It's doing what it's supposed to. What it did over what it should have, 1 over 1. But then clean this up. I'm just going to call that g of x is -x squared plus 2. Now, how do I know that my negative in my final version there, how do I know that's an A and not a B? Because I don't have parentheses anymore. A is out in front of x, B is always grouped with x. The difference between a negative in the A spot and a negative in the B spot is this. Okay? No parentheses tells me it's not B or H. So I just leave it like that. All right. The original, oh, they say it right here, is 1 over x. I will say, because it's been a while since we've seen them, it's A over B parenthesis x minus h plus k is my transformation form for rational functions. Go ahead and write the equation for both. If you need to go back to that first slide when we talked about what the parent function looks like, go ahead, do so. Denied. What? Nothing. What kind of change are you attempting to do? Freaking money bags over here. The most I could do is a 20 because I reimbursed myself in ones last week. You know what it's like when you go through the Culver's drive-through and you pay them in a $38 family order and it's all in ones. God, they hate me.
I do that at Taco Bell.
$13, $14, $17, $18, $19, $20, $21, $22. Oh, you think? Huh? You think that looks suspicious? For about a year, we didn't have a local game store. And to do a pre-release of a Magic event with my game club, I had to meet one of the game store dudes from Rapid, came up to Spearfish with a trunk full of just Magic cards. Like this giant duffel bag full of Magic cards. And I came to him with an envelope full of cash. And we meet in a parking lot. And I hand him an envelope full of cash and walk away with a duffel bag.
That looks so bad.
It looks really bad. I mean, we call it cardboard crack because once you start playing, you spend your life savings on it. But
That's true.
that's an embarrassing conversation. It's like, what's going on here? I'm a nerd. Okay. Look at where the crosshairs moved. Did it move left or right? No. Up or down? So put that in the K spot. +2. Or -2, sorry. Okay. Was it reflected vertically or horizontally? Either. Because it's already symmetric to the origin, a vertical reflection will have the same effect as a horizontal reflection because it was symmetric to the origin to begin with. So personally, instead of dealing with a negative on a denominator and having to factor it out, I would rather put the negative up top.
Wait. There's a
because the original is supposed to look like this. Go back to the parent function sheet at the beginning. That's how the original looks. Okay? And to determine whether or not there was a stretch or reflection, or sorry, stretch or compression, in a normal graph, 1 over 1 is 1. Negative 1, or 1 over negative 1 is negative 1. You should have this idea of right 1, up 1. Well, this went right 1, down 1. It didn't go right 1, down 2. There's no stretch to it. So instead, I just have the negative as my reflection, and that's it. Now, I could write it with the negative out front like this. It's the same thing because we've known for many years now the negative can be in front of the fraction or on the numerator. It's just considered improper to put it on the denominator. This one, I'm going to say g of x is, again, 1, 1. There's still no vertical stretch or compression. But there was a reflection because it's supposed to be over 1, up 1. So I'll put my negative out front again. I did move the goalposts back 4 units to the left. Put it in the H spot, 4 to the left. Plus 4 on the denominator. Okay? Because that's the grouping with x. So you see, no matter what the function itself is, you're talking about what is multiplied by, what is in the grouping with, and what is after x. It's in those 3 locations. A, B, H, and K. Describe the transformations. How did I get the this? And then graph it. I look at the original and I say, first of all, this is mathematical speak for who's your daddy. Identify the parent function. And we'll say f of x is just x cubed. What did we do to x cubed to get the this? Is that 1/4 in A, B, H, or K? It's in the A spot. It's in the A spot, and it is less than 1. So we'll say vertical compression, and you say by what factor? Now, whether something is compressed or stretched, both fall under the family of dilations. Y'all remember from geometry? Like dilate it by a scale factor of 2, okay? But you can also dilate by a factor of 1/3. Dilate just means to change its diameter. That's why when someone says your pupils are dilated, particularly after lunch, they're either really big or really small, depending on what you had for lunch. So now, take each one of your cubes and cut it in a quarter. So over 1 up 1 becomes over 1 up a quarter. Over 2 up 8 becomes over 2 up 2. Over 3 up 27 becomes over 3 up 27 quarters, or almost 7. Over 4 up 64 quarters is 16. And then they're negatives. Negative 1/4, negative 2, negative 27 quarters. Okay. And you notice that with a cubic, having a vertical compression by a quarter didn't actually affect it all that much. Like in the middle, it was a little bit different. But once you got out to 4, 5, 6, it doesn't really matter. And that's because exponents are more powerful than multiplication. So it can be vertically compressed all at once. If you go out far enough, that exponent is going to override it. Okay. Who's your daddy? X squared. The parent function, as simple as it can get. Two things happen to it. What? Notice A spot, B spot, outside of grouping, inside of grouping. So it is a reflection. What? X-axis or Y-axis? Vertically or horizontally? X-axis, yep. So you can either call it a reflection in the X-axis or a vertical reflection. 0.2, 2/10, 1/5 is in the B spot. Go back to your Holy Grail. Since we didn't do as much of this in Algebra 2, a horizontal stretch by 5. Because it's always the reciprocal. It's always bass-ackwards land. This is a horizontal stretch by a factor of 5, always the reciprocal. This is 2/10, which is 1/5, so its reciprocal is 5/1. Okay? B is all about bass-ackwards land. If I take my input and I cut it in a fifth, it's going to take 5 times as long to get where I'm going. Now, 0 squared is still 0, regardless of what I multiply it by. I will reflect it, so it's going to head down. But it's a horizontal stretch by 5. So that means instead of going over 1 and down 1, I'll go over 5 and down 1. Instead of going over 2 and down 4, I'll go over 10 and down 4. And you see, baby got back. Like this is womp. There's, yep. She ain't afraid of M&Ms. Okay. Or maybe we'll set a little mug on it and call it a Kardashian. Or was it a wine glass? I forget. There's a pretty famous picture with one of the Kardashians like doing a booty shot and yeah. Yep. So I don't know what it was. I just remember people were talking about it. All right. There it is. Get it, get it?
Dude, I'm sorry. I'm really trying, but it just happens.
That is a wine glass. This one?
Hey, that one. She looks like a cartoon character. She looks like freaking Jessica Rabbit. Yeah.
Her outfit, she looked like a Dementor from Harry Potter.
Okay. All right. Do the thing. Do the thing. Both those. Tell me the transformation. Make the graph. Oh, we have to do this step one.
kids start your first one at 4.
That's okay.
You know that he's your daddy person.
What is the parent function? Maddie's over here bragging up her $60 an hour. What is the parent function? Now you don't have to make it weird. Game Club's got a sugar daddy. Mr. Joe Hoffman.
This guy.
Joe is a clinical psychologist or a family therapist in California. His family lives in this area. Joe Hoffman.
Yeah, I'm saying, is that family though?
I don't know. He found me online just talking about Game Club stuff. Said, "Hey, I want to send you stuff."
Is it okay?
Yeah, and so he just donates stuff to Game Club. He's a remarkable human being. He's actually very generous. Like, we call him Generous Joe. Yeah. No.
It's just.
Crosshairs have been moved to right here. Okay.
But then isn't that his step thing? Yeah.
Mm-hmm.
I don't like that. Of course, he has to do that one to us.
Of course, I have to have you practice things so they aren't as uncomfortable when you run across them independently.
Ratifying. That's not wonderful. I don't know if there's a report. It's still in November. The temperature is back for a year. Thank you for changing the report.
Because that's where.
Oh, you're doing your stair steps off that.
Yeah. Okay, so what's. So.
Just do it.
This is not the final graph.
Okay, I was like,
This is the parent graph. It's just easier to make this and then... I said that's the most annoying part about these. It's not the function itself, it's making the graph. Okay. That is normal greatest integer function. Step function.
That's exactly you said that right as everyone.
And what will I do to said function? Down 4. So I'm going to take this initial point right here and move this down 4. Okay? You start there and then just make the steps. No biggie. Okay? If, now just because we haven't seen this, what if there is a 3 out front? What else is done to it? Yes, the steps are 3 times as tall. So I would still be there. Uh-oh. Is it? Oh, no. It's because I have triple screen, my laptop screen is actually below this in terms of orientation. I was just wondering if the part of the graph that I moved was down here now. But no, it just disappeared. If I had a 3 in front, it just means you would take a 3 times taller step. So up instead of 1, up 3. Up 1, 2, 3.
I like that better.
Up 1, 2, 3. Okay. And then you get the meme of the guy doing the like 9 steps at once, and yeah. Okay. See, jumping down steps hasn't happened in a long time because my knees are trash, but now if we backed up like 5 years, 60 pounds, and 2 kids, yeah, no problem. So, parent function look like this. I will take that function and do what with it? Okay, so the crosshairs, those vertical and horizontal asymptotes, those moved up 3. And then instead of going from the origin 1, 1, I'm going to go from this, from that crosshair. Now normally, it would be 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third. 1 over a half is 2. Normally. I'm going to take that and multiply it by 15. Which means 15 times taller. Over 1 up 15. You can. Or, what's 15 divided by 1? What's 15 divided by 3? Just use something that's convenient. 1, 2, 3, 4, 5. What's 15 divided by 5? 3. What's 15 divided by 2? So 2 up 1, 2, 3, 4, 5, 6, 7 and a half. Go over 1, 2, 3, 4, 5, 6, 7 and a half up 2. You're just using things that 15 would be divisible by. And then make their inverse over here. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 2, 7 and a half. 7 and a half, 2. Okay. Normally, 1, 5 is a 1.5 to 2 day adventure. Okay. All right. I got to know. Would you rather homework tomorrow? I get this. We just need to do more in class. Or split the assignment into 2 small parts. All right. Welcome to American democracy. People were louder, so they get their way.
Go on a real vacation. Go RVing.